Thank you, and good afternoon, everyone. Today, we're going to look at some updates relating to ISED Canada and FCC, which are very up-to-date, as a matter of fact, including some updates from the past week, and, of course, the most recent TCB workshop. Just a moment, I'm trying to change the slide here. Page down, here we go. Sorry about that. The topics we'll cover include standard updates for radio, RF exposure, and updates on market surveillance, technology, spectrum, and application-related updates. We will start by looking at ISED Canada updates, followed by the FCC. So let's begin with Canada. And the first updates are for ISED certification procedures and requirements. And this first update relates to one of the Canadian exhibit requirements, that is the technical brief cover sheet required for each application. They are providing a revised draft version of the RSS-102 RF exposure technical brief cover sheet, which basically now includes new fields for nerve stimulation and localized power density type assessments. So that localized power density we'll talk about later on. So the RF technical brief cover sheet would be divided into two annexes now instead of one. So there's an Annex A to cover localized power density and SAR, and then there's a separate technical brief cover sheet, Annex B, to cover RF exposure and nerve stimulation. So two different topics per annex, depending on what applies. So either of these would need to be supplied for non-exempt equipment. So ISED will post these revised Annex A and B forms in the next issue of RSS-102. So certification vigilance. During the audit of applications, ISED is catching several applications which do not comply with the applicable requirements. So as an example, ISED found incoming applications for 5G-ready products that did not comply with the current requirements of standards like RSS-192, such as the EIRP limit, the appropriate channel bandwidth, and block edge restriction. And ISED basically believes this is due to the eagerness of industry to introduce new technologies to the market as soon as possible, which sometimes does outpace the actual adoption of adequate requirements in the applicable standards. So everyone must be vigilant and ensure that products do meet the existing requirements. So RSS-247, in terms of 5150, 5250 gigahertz, the indoor restriction, there is a clarification and reminder for RSS-247 in clause section 621, which covers 5150 to 5250 gigahertz. For this frequency band, there is an indoor restriction, and so devices are restricted to indoor operation only in this band. That is except for original equipment manufacturer devices, which are installed in vehicles. So these are permitted. So one of the big changes for you to note, this is pretty major in terms of your compliance strategy for products. Something new in RSP-100, this is the General Radio Standards Procedure for Canada. There is new guidance we've issued for small portable hosts. So for handheld or wearable hosts, like cell phones and smartwatches as examples, that are smaller than 20 centimeters, host certification is required. So a lot of times you're integrating approved modules and you want to know what certification is needed, or do I not need any certifications because everything's approved? Well, they've issued some clear rules. So integration of certified modules without certification is not adequate unless the three requirements are met. And that is that there's only one certified transmitter module in the host, there is no other transmitter in the host, And the SAR, if there, is exempt or is below 0.4 watts per kilogram. So these are the three: one certified transmitter module in the host, no other transmitter, and the SAR has to be exempt or less than 0.4 watts per kilogram. So when there are multiple transmitters, including integrated certified modules, host certification is required in all cases. So there's basically a limit of one transmitter for approved modules being integrated in a host in order to not have a certification performed. So on the next following slide, there's some examples to help illustrate this. So in this example, we can see there's a certified transmitter module being integrated into a small portable cell phone. The SAR level is less than 0.4 watts per kilogram, and since there is no other radio module and the SAR is less than 0.4 watts per kilogram, the device does not need host certification. Now, in this next example, we see there's a certified transmitter module being integrated, but the SAR is now greater than 0.4 watts per kilogram. So therefore, host certification is a requirement here. In this example, we see there's a certified transmitter module integrated into the cell phone. The SAR level is less than 0.4 watts per kilogram. However, there is additionally an uncertified host transmitter. So obviously, because even though the SAR level is less than 0.4, there's a requirement for host certification because there's more than one transmitter contained in this host. And then in this last example, we can see there are two separate certified modules integrated in one cell phone. And this is probably the most interesting place where you'll have a host certification required now. So the SAR level is less than 0.4 watts for each certified transmitter module. However, despite both modules being approved and that fact, there is a requirement for host certification because there is more than one transmitter contained in the small portable host. So next, let's look at ISED's regulatory standards activities for RSS, ISIS, and RF exposure areas. And this is their updated wheel illustration of all the RSS standards available in Canada. It includes standard numbers with frequencies that can be useful. It's very small on the slide, but you will be able to get a better look at that with the slide deck. The green ovals are indicating standards that are licensed equipment and require certification. The yellow indicates standards that do not require a license but do need certification. The blue near the bottom is RSS 310, which is for license exempt, which has a self-declaration. So in the center, you see there are some common general standards like RSS Gen and RSS 102. That applies to all equipment generally, and there is also RSS HAC, which is a newer standard, and there are arrows pointing to it from the mobile narrowband and the mobile broadband sector standards. So this HAC requirement comes into play in future. It's not applicable right now. So RSP-100, there is a new RSP-100 published, issue 12. This is the procedure for certification of radio apparatus broadcasting equipment. It has been revised because a lot of requirements from the previous version were moved to RSS Gen, such as labeling, developmental license, and so on. In terms of key changes, for confidentiality, the procedure moves the confidentiality requirements to section 12.4 instead of 9.4. The rules do now indicate that there is no requirement anymore to obtain ISED permission prior to certification for long-term confidentiality of user manuals and internal photographs. So the certification body can make a decision and submit the application as standard and, with the appropriate justification, and ISED will review the information during the actual well listing process. So the same justification as usual needs to be provided within the confidentiality letter and the supporting exhibits. However, there's no need to submit a permission letter anymore to ISED Canada. So next we look at radio standard specification updates. And in terms of published, for recently published RSS 181 issue 2 for coast ship equipment in the 1605 to 28,000 kilohertz band has been modernized, and they updated the technical requirements to harmonize with international standards. It now covers more than single sideband equipment. RSS 123 issue 4 covers licensed wireless microphones, and this has been updated based on the framework decision that was released in March 2019. And of recent, in the past week, RSS 210 issue 10, which is for licensed exempt radio equipment, has been published on the ISED Canada website. So this is an up issue, and there is a 6-month transition period from the date of published. So the RSS 210 issue 10 will be mandatory from June 2020, but it can be used now. The amendments are numerous, and if you look at the standard, the changes are detailed in the preface section. But they have revised the FRS, GMRS, and GMRS-M, the MERS technical requirements. They've migrated the 24 to 24.25 gigahertz band from RSS 310 to RSS 210. So it now requires certification, that band. They have extended the frequency range from 57 to 64 gigahertz to 57 to 71 gigahertz, based on the millimeter wave decision that was released in June of last year. So in that extended band, there is more Y-gig and motion sensing devices. So they have included technical rules based on wireless microphones as well, which can be used without a license. So in terms of upcoming publications, RSS 222, issue 2 for white space devices. This is updated in terms of the technical rules, and there are new frequency bands that have been assigned. RSS 310, issue 5, which is for licensed exempt radio apparatus. This is category 2, so it doesn't need certification. As described in the earlier slide, they removed the 24 to 24.25 gigahertz band. That's now covered in RSS 210. They have removed user manual e-labeling and receiver requirements, as these are now covered in RSS Gen. They have clarified the technical requirements for AC wire carrier current devices, as some of those would be covered under ISIS 006. And finally, they've clarified requirements relating to infrared frequencies. That's above 3,000 gigahertz. So standards in progress. In terms of the revisions, ready to be released for consultation, basically, before the in the next coming months. There's RSS 125 issue 3, which is for land mobile and fixed radio transmitters and receivers, 1.705 to 30 megahertz. So these are primarily amplitude modulated. They're basically modernizing the document structure, and they're updating the technical requirements to harmonize with international standards. RSS 216 issue 3 is for wireless power transfer equipment, and the main change they're making is in relation to RF exposure. So that is phone-to-phone charging specifically. That's an example. They're updating the limits for wireless power transfer electrical vehicles based on a future amendment to the CISPR 11 standards. They are updating the test methods based on an upcoming ANSI 63.30 standard. So standards under consultation, there's a comment period open. RSS 192, this is one that manufacturers have been waiting for. Issue 4, this is for flexible use broadband equipment operating in the 3450 to 3650 megahertz. The big update here is they're updating to allow flexible use broadband equipment. So mobile and fixed rather than just fixed. So there's a new allowance for usage in this band, which is very helpful. They're updating the technical requirements, that is the limits and measurement methods for non-active and active antenna systems as well. And they're seeking comments on this consultation, and comments are due on March 6th of 2020. So next, let's look at ISED's interference causing equipment standards. So this covers unintentional radiators. So revisions in progress. So the following three standards are being revised, and all of these refer to RSS-216 if there is a wireless power transfer supported. So that's something to keep into consideration. All of the standards have removed the common ISIS requirements, which were contained, and so all the common ISIS requirements are now contained in ISIS-Gen, ISIS-Gen. So ISIS 001 issue 5 is for ISM equipment, and it now refers to the Canadian Standards Association, CISPR 11, 2019, with some deviations. If there is any wireless charging, then RSS 216 will apply. Induction cooking will be covered by ISIS 001. ISIS 002 issue 7 is for vehicles, boats, and other devices equipped with internal combustion engines, traction batteries, or both. And a new issue based on CISPR 12 is introduced here, and they are reintroducing requirements for plug-in electrical vehicles, boats, and devices. ISIS 003 is for multimedia equipment, and the revision will be in issue 7. It refers to CISPR 32 instead of CSA CISPR 22 for the scope, measurement methods, and limits. They do, however, continue to accept the ANSI 363.4 for radiated emissions and conducted emissions on AC mains power lines. So there is an ISIS host compliance reminder. In respect of the ISIS standards that we've been discussing, ISED wants to remind host product manufacturers and applicants that when integrating radios into a host, please remember the host compliance with the applicable ISIS standards as well. So host products are not required to be certified separately, provided they do not contain any non-certified transmitters. And all the intentional radio emissions are generated by the integrated certified modules. So in the example they show in the bottom there is a host with 2 modules contained in it. A host containing only the certified transmitter modules are exempt from the ISED certification, ISIS labeling and reporting requirements. That's ISIS standards. However, the host must comply with the emission limits set in the applicable ISIS standards. So if there is a processor in the host, then ISIS 003 would apply. Okay, so there are movements in the development and amendment to regulations in the area of international and domestic standard activities on RF exposure. It's a pretty hot topic for many manufacturers and labs and so on. So in terms of the international standards activities on RF exposure, first we look at 2 computational standards. There is the draft IEEE 62704-4. This is the final draft international standard. This is SAW determination from exposure to portable devices using the finite element method, and the expected publication is in February. There is the draft IEEE 63195-2, and this is at the committee draft for vote. And this addresses power density computations for devices with a frequency greater than 6 gigahertz. So portable devices based on power density averaging and associated test algorithms is covered in the standard. So work is in progress still, and users must contact ISED before initiating the certification process to determine if this computational modeling method is acceptable. So in terms of international activities for measurement standards, there are some updates. The 4 to 10 gigahertz draft standard, IEC 62209-1528, is a unified standard. for head and body star measurement, and that's due to be published. IEC 62209-3 is an international standard for vector probe systems, and this was published last September, but is not adopted for certifying wireless devices. So on January 9th, actually, of this year, ISED Standards Branch did release a notice 2020-DRS-0001, which outlines that Canada does not accept the IEEE 62209-3 standard for compliance demonstration for SAR. And then finally, the draft IEC 63195-1. This is for power density measurements above 6 gigahertz for portable devices. And the committee draft vote is, I think it was expected towards the end of last year. So ISED published notice 2019 DRS-001 last September, which relates to IEC 62209-2. RSS-102 references the latest version of the IEC 62209-2 standard, which is for SAR of wireless devices used in close proximity to the human body. IEC 62209-2 amendment was published and can be used on a voluntary basis. However, it is mandatory to use this from March 1st of this year. So in terms of consultation for domestic standard activities, SPR-003, Issue 1, has been released for comment. It's a procedure for assessing the radio frequency exposure compliance of portable devices operating in the 60 gigahertz band. So this next revision will expand to all devices above 6 gigahertz, not just within that band that you see there. The assessment approach is based on simulations and measurements, and the consultation is closed. ISED's addressing comments that have been received. So upcoming revisions for domestic standards, there's RSS 102 Issue 6 for RF exposure. This is under revision, and they're introducing localized exposure limits for portable devices operating over 6 gigahertz. They're also reviewing the exemption limits for SAR, including an extension of frequency bands and distances, so that shall be quite useful. They are still considering exemption limits for routine nerve stimulation evaluation, so that's been ongoing for almost 2 years now. SPR-002 Issue 2 is a supplementary procedure for assessing compliance with RSS 102 nerve stimulation exposure limits. And they are establishing procedures for new types of applications, such as smartphone to smartphone charging. And then RSS 216 Issue 3 for wireless power transfer devices is under review for items relating to RF exposure. So we'll look at updates from the FCC next, and starting with a few key updates in the administrative side of things. The FCC equipment filing system was planned to be released. However, there were some resource and budget issues as they're in the process of testing the new server with higher storage capacity. They do have plans to bring it online in the near future, which will involve system downtime. TÜV SÜD will provide advance notice to manufacturers of any downtime once we are informed by the FCC of this. So this next administrative update is relating to the SDOC, the Supplier's Declaration of Conformity. Now, this is a reminder the FCC presented on. This Supplier's Declaration of Conformity replaced the old verification of DOC authorization routes. So the FCC provided a very useful overview of this Supplier's Declaration of Conformity authorization route. The SDOC is very important in most devices that are certified. So for most devices that are certified, there's likely a need for an SDOC as well, so it's something to be really aware of. They basically provide this little table here. SDOC is covered in FCC Rule Part 2, and they provide an overview of SDOC versus certification authorization. So this chart can be referenced and used as a cheat sheet. for SDoc, there is a requirement that the product be uniquely identified. So model numbers or serial numbers can be used, for example, to identify that product. The use of the FCC logo is optional. So originally the logo was used to show that the device was tested at an accredited lab. But now the logo relates to the use of the SDoc scheme. So for SDoc compliance, the information for the user needs to be provided and should cover information about the product, the responsible party, who must be located in the United States. So devices permitted SDoc can also have the option of using the certification route. So that option does still remain. And e-labeling is available to both SDoc and certification. So the interesting part was the clarification on this table, which relates to the 15.19 and 15.105 statements. The 15.19 statement was normally on the product if it was large enough, but for SDoc, they say that if it is not practical for your company's image to show the statement on the device, it can be placed in the manual. And if the manual is not provided at the time of sale, then the statements shall be required on the packaging or the pamphlet. The next useful clarification was that the 15.105 Class A or Class B statement does not need to be included in the manual if the 15.19 statement is in the manual. So the 15.21 statement does, however, still need to be in the user manual. So they are going to update the SDoc guidance documentation. SDoc applies to other rule parts other than just 15B. So they provided this little reminder here on this slide. You can see that there are other rule parts that can apply for us, use the SDoc authorization route. In rule part 15.101, there is a list of devices that are SDoc or certified. For part 18, there's an option to follow SDoc or certification. For Part 73, all broadcast transmitters can follow SDoc or certification, except for Rule Part 73G, low-power FM broadcast stations. That does require certification. But importantly, for 15B, if the aspect is not certified, then most certified products do have an SDoc component. So a PAG reuse procedure, this is the pre-approval guidance procedure, has been in place for a few months now. That is a reuse procedure, so a way to make the process of a PAG quicker if you have a manufacturer with a pretty similar device and the same PAG cases applying for this product that you have. So there's a quicker way they've introduced. Basically, there are cases where a manufacturer has a device that falls on the PAG list, the FCC's PAG list. These are typically more newer type innovative devices which need FCC's oversight. They go through a PAG procedure, and then it's granted by the TCB. So normally, you have a device that goes through the PAG procedure, it's granted. In future, if you have another product with the same PAG item, topic, and scenario as a previous PAG subjected device, so the PAG is exactly the same. So the FCC introduced this reuse procedure, so you have to go through the whole process, and there are 3 steps that are part of a PAG reuse procedure. But a PAG and a PAG reuse is not the same as an open reuse inquiry. But the inquiry does not hold up the issuance of the grant, this new procedure they have. You basically submit a reuse inquiry instead of a PAG. And there is a breakdown of the steps for this PAG reuse procedure that is provided here on this slide for future reference. So next we look briefly at update and status of select ANSI C63 standards. First, C63.4A for unintentional radiators. There is a public notice that was released April 2nd, seeking public comment. That comment period is closed. Comments were received on the proposal to incorporate the standard into Part 15 of the FCC rules, and this is still being considered. There is a C63.4 unintentional radiators full revision ongoing, and the working group is pursuing that to complete the revision. There are many changes, such as new radiated test site requirements for validation from 1 to 18 gigahertz that is being progressed. C63.10, which is for unlicensed wireless devices, has undergone a full revision. It's currently in the balloting stage with publication anticipated in early 2020. The revisions to ANSI C63.26 continue. There are updates to the radiated emissions and signal booster clauses that have been completed. There are new compliance test procedures for millimeter wave devices under the new FCC Rule Part 30 requirements and radar devices to Part 95M requirements. There has been recently completed and been integrated into the standards. The MINO task group provided a methodology for determining the far field distance by measurement instead of by calculation, which will be included as an informative appendix. And the publication of measures anticipated this year sometime. So for other C63 activities that are undergoing updates for test procedures, there is C63.29 for RF lighting products. There's C63.30 for wireless power transfer products, and C63.31 for ISM equipment. So there's a test report and data reduction working group topic that was discussed, and the FCC basically opened a dialogue to discuss potential test data and reporting reduction opportunities. So as we know, the various combinations of modulations, coding schemes, power levels can mean that a strict interpretation of the rules to measure all possible combinations can be a cumbersome process. But TÜV SÜD is taking part in the working group to participate in a joint effort to identify possible ways and means for reducing the requisite reporting and testing. So next we can look at a follow-up on the FCC's new Part 95M updates for vehicular radars. So recent Part 95M policy issues, the FCC are fielding questions and inquiries relating to the ability to use in-cabin vehicular radar applications in the 76 to 81 gigahertz frequency band. So that, at the moment, the KDB publication 65305 does state that radar devices intended solely for in-cabin, automotive usage cannot be accommodated under the rules. So there are concerns over combining in-cabin and external radios under the same rules. So the current policy for Part 95M rules is specific to vehicle-mounted radars used to detect objects outside of the cabin, but within the proximity of the vehicle, or for in-cabin sensors that are integral to such externally dedicated sensors. Anyway, compliance measurement procedures for Part 95M radar applications were recently finalized in the C63.26 task group in October. The FCC is formulating guidance based on these procedures. It is being prepared, and they're hoping to have it out for comment. The FCC did provide an overview of the test procedure for this, and although the FMCW radar modulation scheme types are what they've seen so far, compliance test procedures applicable to traditional RF pulse radar are also included in the C63.26 guidance. The procedure does provide detailed guidance for measuring the occupied bandwidth, the output power levels, the unwanted emission power levels. There are no requirements under Part 95M to stop the frequency sweep or to limit the duty cycle consideration to within a 100 millisecond period, as is required under Part 15 rules. So they are looking at true average measurements. Next, let's look at updates on 802.11ax and narrowband IoT. The FCC reminds that any device that supports channel puncturing, 802.11ax, for the channel close time and move time, 2 channels need to be tested. So in the example on this slide, channel 104 could be tested for both the channel move time and close time tests. And then once that's punctured, test on another channel, for example, channel 100 for both the channel move time and close time. So narrowband IoT has been posing challenges to manufacturers and TCBs. There are FCC Band 12 and Band 13 are the bands, and these fall under Part 27. The FCC rule states that there should be no less than 30 kilohertz of resolution bandwidth from measuring the band edge emissions outside the band. However, many devices have been certified with much less than the required resolution bandwidth. So the FCC and the Wireless Bureau are looking at non-conforming devices to come up with the required resolution bandwidth, and they will update once the resolution has been reached. So 3GPP and the FCC do have different frequency ranges. But the 3GPP has a 1 megahertz guard band on the outer edges. And there might be other bands that have similar issues. So the FCC has some solutions for devices that have been granted or close to being granted. The first option is to move the lowest and highest channels in from the band edge. In future, then, they can expand band with a permissive change application. The second option is to reduce the power. And the third option is to have better filtering. So for duty cycle, the FCC have relaxed the requirement for applying the duty cycle correction factor. In the past, it was allowed only for certain equipment like Zigbee or protocol limited devices. And this protocol limit is removed now. So it can be used as any digital transmission system device as long as the spurious emissions fall in the restricted band. The duty cycle should be measured in a maximum of 100 milliseconds window, and how that duty cycle was derived should be explained in the test report. So they also allow the duty cycle correction for frequency hopping devices. So for Bluetooth or any FHSS, it can be used as long as spurious emissions fall in the restricted band and based on a 100 millisecond window. So next we'll look at citizen broadband radio service device updates. This is Part 96, and there is a KDB 940660 that applies for these type of devices. So for citizens band service devices in the filing, the power should be listed as a total EIRP over the entire bandwidth. So this is reminders. The grant note AP should be included on the grant for CBSDs. And there are some terminologies like CPE CBSDs. These are CBSDs that do not have a direct link to a SAS and operate through a pre-authorized base station, which is called a BTS CBSD. So this is all terminology from their KDB 940660. For a CPE CBSD, the test procedures must show the timing requirements must be shown clearly. This is the time requirement for how long the device should be on before it can be authorized by a base station. And an example of how to do that would be through time domain sweeps, where the aggregate amount of time would be added up. They want to see the SAS registration operating below 23 dBm as an example, through doing a time domain sweep, and set the CPE CBSD max EIRP to less than 23 dBm. And after the SAS grant, adjust the EIRP to above 23 dBm. So in terms of the KDB, it has been updated in terms of the DO2 document to include the equipment authorization procedures for CPE CBSCs, including guidance to state, include grant note 40. This device may be operated as a CBSC CPE subject to configuration and control protocols as specified in the filing. The CPE CBSC must register with a SAS irrespective of the power levels at which the device operates, including below 23 dBm. So for signal boosters, there are some ongoing rulemakings and rule changes that are coming. However, for now, they are updating the KDB publications for minor corrections. There have been questions relating to confirmation of the passband, what frequencies the device amplifies, and so they are going to include a generic condition in the test procedure in the KDB publications, DO3, DO4, DO5. They will ask that applications include information about how the booster rejects signals outside of its passband. So this is I thought this would be useful. There's a Part 87 equipment authorization process, and the FAA officer provided an overview of that, including the FAA approval. Part 87 equipment includes safety of life equipment used on aircraft and states that an application for certification of equipment intended for transmission in any frequency band listed in Part D3 of the section that is in Rule Part 87 must notify the FAA of the filing of a certification application. So there are two phases and types of requests. Type 1 is testing and development phase. There is a frequency assignment required for the testing, which does not involve the FAA. And then number 2, there's a final operational phase where the equipment's ready to be sold to the public. And this is where the FAA reviews. So these are two different types of requests. So there's a little diagram here of the review process between FAA versus the TCB FCC equipment certification process. So, but briefly, the manufacturer first submits to the FAA Spectrum Office for the FAA determination. The FAA provides the manufacturer with either notification to proceed with the FCC certification, or correction actions are requested in their letter. If there is a notification to proceed, then the manufacturer obtains an FCC certification through the accredited lab, and the TCB does the approval. The manufacturer must provide the FAA's notification to proceed letter to the TCB, which has to be included in the filing as a public record. So the TCB cannot grant the certification without FAA's notification to proceed. There is an optional experimental licensing. This is where the manufacturer has the option or is under the direction of the FAA to do a field evaluation trial under FCC Rule Section 2.803 and 2.805 prior to an authorization by applying for an FCC experimental license. So this slide basically has a summary of the process as was illustrated on the earlier slide. So some changes did occur at the FAA in recent years, so the latest FAA contact information is provided here. So next we look briefly at the KDB Publication 662911 updates. This relates to the MIMO measurement option. So first topic, directional gain of devices in the antenna system. KDB Publication 662911 describes a method to calculate the directional gain of a multi-antenna system. The FCC knows the method may overestimate the actual gain, so they're proposing to permit an alternative method to use appropriate antenna gain measurement results instead of theoretical calculations. So there will be a complementary guidance document to the KDB, which will be published to address how they want the measurement to be conducted. And approval is on a case-by-case basis, and it is subject to a PAG procedure. So for the antenna gain measurement, the FCC provided their requirements and expectations. When submitting antenna gain measurement results, the following items should be sufficiently addressed, and that is identification of the measurement environment, the measurement method, and how it's defined, a clear defining of the measurement quantity, and that is in measurement of the gain, directivity, radiation efficiency. And then for the more advanced antenna systems with beam forming or beam steering, there are additional identifications required. So next we can look briefly at Part 30 updates. To perform compliance testing, 3 methods are actually recommended in the Part 30 KDB for making the out-of-band and spurious emission measurements. The first method is radiated EIRP measurement, and if the measurement meets the limit specified as total radiated power, then it's fine. The next step is to make a direct total radiated power measurement in the out-of-band spurious domain. And in very specific case, they allow an indirect type of measurement, which is where they make a radiated EIRP measurement. So overall, fixed transmitters which have been authorized all took advantage of all of the recommended methods. But almost all applications, however, did utilize the third method to meet the out-of-band limit at the band edge. So a limited number of applications perform TRP measurements, which is the FCC's preference. The third method is the indirect radiated EIRP minus the antenna gain. This method is only allowed for the band edge of Part 30 devices. So as applicable to Part 30 devices, use of the method is only allowed at the band edge and is subject to a few conditions. Rule Part 30.203 defines the band edge as 10% of the channel bandwidth removed from the edge of the band. And 2 key points relating to this is that the band edge changes as the channel bandwidth increases or decreases. So it does not define the boundary separating the out-of-band domain from the spurious domain. So a more comprehensive way of performing the unwanted emissions testing would be using the TRP measurement method. And if the radiated EIRP measurement results do not meet the unwanted emission limits as stated in the rule part, then TRP measurements are performed. And these may be performed anywhere in the unwanted emission domain. A few applications used that method, mainly through the two-cut method as described in the KDB publication, 842590, and that was the millimeter wave device procedure. So next, the FCC provided a method for reducing compliance testing for multiple antenna systems. Most of the advanced antenna system technology the FCC has seen, such as beam forming, beam steering, and such, there appears to be a common practice for phased array antenna systems with subarrays. The number of radiating elements vary from 4 to 256 elements per subarray. But what they found is that if the subarrays are identical, then you do not need to make measurements of each subarray. If using multiple subarrays to make one radiating beam, the total power needs to be calculated due to the radiation contribution from all arrays. Once the beam is at bore site, they are allowing one beam position corresponding with the maximum radiated power to be tested for compliance purposes. So for compliance measurements where there are multiple modulation schemes, the FCC has found that when the in-band power level was compared across 3 distinct modulations, there were no remarkable differences. So for compliance purposes, one modulation of the lowest order may be selected for testing of the in-band power. So next we'll look at 5G, new radio, and ENDC compliance test configurations. Very briefly, 3GPP does define multi-radio geoconnectivity as a geoconnectivity mode of operation that allows user equipment to utilize resources to connect to two nodes with different radio access technology. The FCC are trying to find ways to minimize testing of such devices. Radio nodes, in the case of geoconnectivity, may simultaneously transmit two technologies, such as 4G LTE and 5G NR, so additional combinations are introduced to the test configuration. All combinations on the 4G and 5G side would lead to a lot of test scenarios. There can be carrier aggregation and different rule parts as well, so they are trying to find ways to minimize the testing. In terms of general guidance for geoconnectivity, for test frequencies, 3GPP compliant devices may follow the TR 38.508 recommendations to select a channel. For operating bandwidth, all possible combinations of LTE and 5G NR should be tested. For modulation, only the worst case of each technology needs to be tested. And when combining them for simultaneous transmission, only consider worst case configurations. For other variables, such as resource blocks and subcarrier spacing, there is a need for a judgment call on what scenarios can be implemented as available per technology. For simultaneous transmission, there is more detailed information, however. It is acceptable to determine the worst case configuration of each technology and only include the worst case in combinations for RF power and out-of-band various emissions. So let's take a brief look at the spectrum proceedings. The FCC has a 5G FAST plan, which is an overarching policy initiative they're focusing on. There are a variety of rulemakings covered under that umbrella. In the high band spectrum frontiers, they're getting ready to auction some upper bands. And in the mid-band, like 2.5, 3.5, and 3.7, they're acting to improve spectrum in that area. And in the low band, in the unlicensed spectrum, they're looking at license potential in the 6 gigahertz and 95 gigahertz band. So the FCC did come out with more usage initiated above 95 gigahertz. There was a proceeding that was adopted last March. The rules are not effective yet. They're allocated 21.2 gigahertz of unlicensed use, and they reflect the ISM bands that are allocated. They came up with an experimental license for above 95 gigahertz, which allows a 10-year license, and they relaxed some restrictions on selling devices. There is a pending proceeding to expand unlicensed use in the 6 gigahertz band. It's a little small to view on the slide. It's UNII 5 to UNII 8 on this slide. The FCC proposed an automatic frequency coordination in these bands. And to enable these UNII bands, the FCC are recommending in 2 of the bands that an automatic frequency control is supported, and indoor and low power only for the other bands. And a year ago, they added a lot more mobile bands in the spectrum frontier rulemaking, and you can see here they added 12.55 gigahertz of spectrum for mobile use. There was an auction on some of the bands last December, and there will be more devices operating in the Part 30 upper microwave flexible service. So relating to the mid-band, the FCC is seeking to facilitate shared use in the 3.1 to 3.55 gigahertz band. In December, there was a news release relating to changes in the 3.1 to 3.55 gigahertz band, which would be the first step to making spectrum in that band available for advanced commercial services like 5G. They released a full statement and they seek comments. On December 16th, they released an NPRM, which is not yet published in the Federal Register, and by proposing to delete the existing non-federal secondary allocations from the 3.3 to 3.55 gigahertz band, they are taking an important initial step to satisfying the Congress's directives and making 250 megahertz of spectrum in this band available for advanced wireless services, including 5G. So for RF exposure updates, this is a summary on this slide of the main topics discussed at the workshop, which relates to SAR and RF exposure. Due to time, this won't be covered in full. However, just some interesting points. The first item is SAR to peak location separation ratio. SPLSR hotspot combination, that is an item they provided some information on. They referred to it as SPLSR during the presentation. Secondly, there's a vector measurement-based probe array SAR system. This is still being evaluated by the FCC, so is not acceptable for full compliance testing demonstration. The last item is basic MPE evaluation and test exclusion for portable devices operating at a frequency over 6 gigahertz. So this topic we'll look at on the next slide because it's kind of interesting. And so basically for portable devices operating over 6 gigahertz, the FCC has opened up a 1 milliwatt test exclusion, which devices can use now to meet SAR exemption requirements. So, you know, before it was only for medical implant devices or devices less than 6 gigahertz that there were SAR exemption rules. But they have now, for over 6 gigahertz device, opened up an exclusion, but the maximum time average conducted power has to be less than 1 milliwatt. But we have seen this being useful in recent applications, and applicants are making use of this. So portable devices operating over 6 gigahertz would be excluded if they meet that power exemption level. An analysis exhibit would still be needed, but otherwise portable devices, if they exceed that power level, still remain addressed on a case-by-case basis with the TCB and the FCC. And that concludes this the webinar portion for me. Thank you.